Hello, this is the lesson for your very first assignment of the year. You're going to have to navigate to our first learning plan template, and that will be somewhere in Canvas, and I will show that to you perhaps on the first day of class. And then you're going to probably want to watch the meta calculator video before you start, and this will be in the very first assignment here, standard form quadratics. So, without further ado, let's get my overhead up here. You're also going to want to print out the notes and reference material. I don't know how much copying we're going to be able to do. So you're going to want to have that downloaded or printed out also before you start. So you'll see this page, notes on quadratic functions, and then notes on domain and range that you're going to want to have printed out before you get started. So, without further ado, we'll start on this first assignment. And you're going to want to have a graphing calculator or the meta calculator ready to go because you're always going to need to get a table from the given quadratic function. So what are quadratic functions? Quadratic functions are second degree equations, meaning that the highest power in the statement is a squared. That always has to be there. And there could possibly be an x in the quadratic given, and then a constant added on the end. That's if we're dealing with what's called standard form, or I call it quadratic form. That's what we're going to deal with today. There's also vertex form. And so this is just written a different way, but it still will produce a quadratic. And then everything you see here is going to be defined upon the values of a, b, and c within the given quadratic, or the values of a, h, and k if the quadratic is written in vertex form. So what use are quadratics? Quadratics have a wide variety of uses, especially in science and free fall physics. Also, they are used to model area problems in mathematics quite a bit. So that's two applications that we're going to do, and there are other applications of quadratics. So it is a very important function to get to know, and that's what we're going to be doing this week, is getting to know quadratic functions. All right, so we will begin. There are 8 problems on your assignment, and typically what I do is I just get in here and show you how this works. And you can use, again, a graphing calculator. Don't worry, though. Use the online meta calculator. It's really very simple to use and will probably be good because there'll be some times when you don't have a graphing calculator for sure. So all these problems are going to be in standard or quadratic form. So the reference material that you need to look at will be right here the whole time. So you want to, first of all, identify the values of a, b, and c, and you have to think in terms of addition. So the coefficient of x squared, that's the value of a. That's 1, plus negative 2x. So the coefficient of b is, or sorry, the coefficient of x is, we call it b. The b coefficient is negative 2. And then the constant coefficient added on the end is negative 3. And everything is going to revolve around those 3 values. So you've got to make sure you get it right. Just slow down, double check those. You have to think in terms of addition. So what I'm saying is, if I wrote this in terms of addition, you would see the negative 2 and the negative 3 for B and C. Okay, so the next thing you need to do is you need to get a graphing calculator or the Meta online calculator, enter in the equations. So you're going to have to know how to use a graphing calculator. So watch as I do the explaining. So there's your x key. You're going to go to y equals. There's your x key squared. and then minus 2x minus 3. And so you're going to have to make sure, if this doesn't look right, your mode, we should probably be in degrees here. Make sure your mode says all of this and then go to next. So if you don't have all of this like you see here, you need to get it set that way. So if you're not seeing your y equals for some reason. There it is. Now we need to set our table. And once you set your table, it should be good. Although if you get a decimal vertex, then you're going to have to be clever with setting your table if you want to try to get it to show up on the table. Then you go to your table. So second table set, second table, and you start looking around. And what you want to look for, so I see the vertex right now is 1, -4, because above and below the -4, I'm seeing these paired y values that are the same. And that's how you know that you have the correct vertex. So 1, -4 is it. You can also calculate the vertex. So what do I mean by calculate? You can do this formula and then just go to the table with that value and start your table there. And that's going to happen sometimes when the x value of the vertex is not very nice and we can't just cheat and look at it on the table. Here we could cheat and get it right away. But what if you don't see that pattern? Then you have to calculate it and start your table there. So what I mean by calculated is doing this. Using those values of A, B, and C, you'll see that you get 1. Okay, opposite of B, which is -2, so that makes a +2 over 2 times A. So you can always do that, and then you would just go to 1, or you might have to adjust, and let's say it was 1.1. Then you just start your table there, then you know that you are going to pick up the vertex. Okay, so from here, you want to just put in a couple of more points around 1, -4. Now, I usually pick points that are a little bit removed from, so like 2 away. So if we go -1, 0, these happen to also be the x-intercepts, so there's a ton of stuff to learn in the patterns. So if you have zeros on the table, those are the x-intercepts. Okay, now they don't always appear on the table, but for most of the problems that we do, they will appear. Okay, so I usually look for those. If they're not there, I just look for points close to the vertex, but usually a couple of notches, so a couple of x values, so 3 and -1. You can also take a look at the graph just to, how is this going to look after I graph it? So that's how it's going to look. All right, so I keep getting this advertisement coming up from my document camera software that keeps annoying me. Okay, so you need to, from this point, just go through this, and everything is pretty simple once you get the vertex. So your axis of symmetry is just this vertical line that runs through the x value of the vertex. The maximum or minimum, in this case, since this opens up, you have a minimum at the vertex. You pick the y value and you just put it in here. So it goes in one of the other places there. And just literally, if you can't tell from your table, you have to go to the formula sheet. It's that simple. But just like I showed you with this, if you couldn't see the x-intercepts on the table, then you have to go to the quadratic formula, the -b plus or minus the square root of b squared minus 4ac all over 2a. Some of you might have remembered that from last year. But most of the problems for right now, just getting started, are going to be, you're going to be able to see those x-intercepts on the table because I think that's very important. So the y-intercept is simply the c value. And all of this can always be found on that little recipe page there. The domain. So for all intensive purposes right now, unless we have an applied situation, the domain will be all reals. So this is a way in interval notation of writing all reals. So the negative infinity and the positive infinity are the left and right endpoints of all the possible x values that can make this graph up. So you'll notice I gave you some domain and range notes here. And so I'm going to show you the box technique with this. And what's going to happen is you're going to get either the bottom of the box or the top of the box around the quadratic. It's just going to have one side of a box that you try to draw around it, and the other sides, there will not be a way to put the side of the box because the graph keeps extending in that direction without end. And so I'll show that idea when we get to it. So the range, and I guess we're to it right now, we want to graph this quadratic, and so you can use this nice little picture of the graph. So y-intercept is -3. And there's all these symmetry points. So the idea of symmetry, here's your vertex, and so there's this axis of symmetry that runs through it. That's what the x equals 1 was. And so the points are located at a symmetric distance. So if we have this one, then we go 2 to the left, and we have that x-intercept. So that's good to use that all the time. So what I mean by the box, so the idea of this quadratic is that it actually keeps getting wider and wider and wider this way. So there's no way to get the left and right side of the box around this. And that's what this is getting at right here. And so we put infinities in the left and right ends of the domain statement here. And then, of course, erase the equal to part because you can never be equal to infinity. So depending upon whether there's a bottom or a top to this, will be where your number goes that represents the top or the bottom of the box and in your infinity. So I can actually put a bottom side of this in right here. And so that goes through the -4. So that's going to be on the left side of this double inequality. So the ends of these double inequalities represent sides of a box that you're trying to draw around the graph. And if you can't get that in, then there's an infinity that goes in that part of the double inequality. So this was the left side of the box. This was the right side. This was the top. This is the bottom. And so typically you try to go through, now you don't have to every time put in the bottom, the top, and the left and the right. But just to show you, I did this time. All right, so that'll be that way all the time in all the ones we study. Certainly you can make quadratics that have endpoints and you can get an entire box around them. There are graphs where you can get an entire box around it, and then these values will take on, you could have 4 numbers in the places of those infinities. Factor if possible. I am just going to put this down. This is not going to be on your first quiz. To see if you can start figuring out how is factoring related to the x-intercepts. There is a rule. And right at first you go, oh, well, I think I have it. It looks pretty simple. And actually it is for the most part, but when you get to some fraction x-intercepts, it's a little bit harder. Intervals of increasing and decreasing. So that's separated by the axis of symmetry, and you use the x value of the vertex. So I just trace left to right. So look at as I trace this. I'm decreasing up to 1, and I'm increasing after 1. Okay, so what I typically do is I just think of it this way. This side is greater than 1. I'm thinking in terms of x. This side is less than 1. The mistakes that students will make on this is that they will not trace this and associate it correctly. So I'm going to write these in all the time. But you need to trace it and use the x value of the vertex, not the y value. That's what I meant to say. The mistakes that students make, they typically use the y value. So x value, put the 1 in and not the -4. So x less than 1, it is decreasing as you trace left to right. So that goes here. And then greater than 1 here. So you got to trace it left to right. You got to put those two inequalities in. End behavior, very simple. What are these ends doing? As x gets way out to the right, so these ends are going up forever and ever. The top side of the box is not possible to draw. So these are either both going to be positive infinity or both be negative infinity. All right, that's problem 1. Problem 2. So I'm going to pick this up a little bit to make this go faster and talk about the things I need to talk about. And so I'm not making this video too long. So 4 minus x squared. This again is in standard form. A is -1, B is 0, and C is 4. And this is going to open down. Now, why is it -1, 0, and 4? Because you have to get in your mind that the a value is multiplied by the x squared term. B value is multiplied by the x term, which is not there, and then the c value is the number added on the end. A can never be 0. B and C can be 0. Just depends on what's given. So you will see, again from your table, that the vertex point, and by the way, you have to include the vertex in the graph. I didn't say that in the first problem. If you don't do that, it's wrong. You can't just go to a table and write anything down. Okay, so I know this is the vertex, 0, 4, from the table because above and below it, wonder if I'm ever going to get that ad to stop. That's going to really annoy me if I can't. Okay, so as I was saying, above and below, in the y value part of this, you see the same y value, so you could go beyond 2 and you would see whatever. That's the pattern for noticing the vertex. And that's a pattern that's really very important. Should probably show this again since I'm doing this. So you need to get it into a graph or go to the table. So you see that whole pattern there above and below the 4. Very important. All right, so I'm going to go pretty quick now on this because I'm using more time than I wanted. That will probably always be the case. This is a maximum value at y equals 4 because this opens down when you look at it. So it's a maximum and the minimum does not apply. Axis of symmetry, x equals 0. X-intercepts at -2 and 2. Y-intercept is at 4. The domain is all reals. Yes, that's always going to be true. And now let's go graph this. 2 and -2 and 0, 4. Please, when you draw this, you got to try to make the curves right. And you must get the vertex in. If you do not get the vertex in, it's going to be wrong. So make sure you do that. And then on the top here, you get the top side of the box in. So in the range, that's going to be on the right now. So you have to really maybe look at the notes and try to make heads or tails of this. Usually people kind of cross their eyes when they look at my notes, but so you have the right side of the inequality here because of the top of the box. So you'll get it in time doing enough. So factoring x plus 2 times x minus 2. See if you can figure that out. Intervals of increasing. So we put a vertical line through the vertex, and the left side is less than 0, the right side is greater than 0. But you need to figure out what is it. Trace it left to right. Okay, so I'm increasing for x is less than 0 and decreasing for greater than 0. And behavior. Where are the two ends of the graph going? They're going down. This will be pretty easy to do once you do a lot of these problems. So number 7 will be next. I thought I had that. There it is. It's been a while since I've done a video, so I'm not looking too good in this one. Okay. So still standard form, that's what you're going to have. One thing you should do, every single one you do has to look like one of these three, opening up or down, one of these 6 I should say. And so what we had last time was something like this. What we had first time was something like that. This one's going to be something like this. So you should always be able to look at those pictures and figure out what is going on. So you need to go to a grapher and look on the table and see if you can find that pattern. I'm going to tell you the single most important thing you're going to have to know. I see it. There it is, -1/6. In using a calculator, graphing calculator, is how to enter a function and use a table. It seems simple, but a lot of times it's not. Okay. Once in a while I'll pause to make sure I'm still recording or I haven't hit pause, so excuse me for that. So -1/6 is the vertex. Again, this is problem 7. So make sure you're on the right problem as you're trying to take notes here. So that is the vertex. And since this opens up, we have a minimum at y equals 6. Axis of symmetry is x equals -1. The x-intercepts, there are none. So actually, let's look at this. So you're going to have to get used to seeing these in all their different ways. So I'm going to use the y-intercept and the idea of symmetry. So here's the y-intercept, and then you go 1 to the left. That was kind of ugly there. So there's your graph. Y-intercept is 7. Remember, that's the C value. Domain, all reals again. And the range, this time you have the bottom side of the box that goes through 6. So that's going to be on the left side. And yes, the inequalities always point the same way all the time. Okay, what's the domain? The set of all x's that make the graph up. But I like the box technique, so I'm trying to put a box around the graph. I can only get the bottom side in. That means that in the 4 parts of these double inequalities, compound inequalities I should say, that only one of them is going to be a number. If I can get all 4 sides of the box in, then all 4 of them have to be a number. Let's say I get 2 or 3 sides of the box in. Then, I don't know if it's possible to get 3 sides in, then you have 2 or 3 parts that are numbers. So that's a good technique to learn. It's not foolproof, but it'll work 90% of the time. Some of your graphs just get more complicated, and you might have to put several boxes around piecewise graphs or something crazy like that. All right, factor if possible. No, it's not because you don't have rational x-intercepts. There are none. Intervals of increasing and decreasing. Well, that's where you put this vertical line through here called the axis of symmetry. And this is less than -1. This is greater than -1. Please do that. Just write that in there. The two separate sides always going to be less than, greater than, like that. And then just trace that. So this is where it's decreasing. X is less than -1. I think even if you put that there, I might give you credit. You're going to have to put it in down here, but that's showing me you know how to analyze increasing and decreasing. That's really a simplistic version of increasing and decreasing. You're going to learn a lot more about it in pre-calc if you do pre-calc, and or if you do calculus, but it will work for now. It has to do with maxes and minimums in the graph. And then these last two are infinity, because that's where the ends of the graph, that's where the ends of those infinities are bad. I'm rusty. I haven't done videos since April, actually May. But you just look at the ends of the graph, and so they're both going up. That's what will tell you goes there. So learn how to navigate in Canvas. I will have these in one place. I'm not sure yet. There comes the advertisement again. That's going to drive me crazy. But the first day of school, I will tell you.